Hello everyone, welcome to PW. Good evening everyone. Please let me know by writing in the comment section whether audio and video everything is perfect or not. I know most of you are waiting from very long to start this digital electronics, and it's my promise to all of you that this particular subject is going to be one of the most favorite subject in your entire engineering is going to be very soon. Okay, so please let me know once by writing in the comment section whether audio and video everything is perfect or not. Great. One more thing I just wanted to all of you, this batch is an English batch, but it anyhow will not affect to anyone because I am going to use very simple language which can be understood with everyone in a very easy way. Is it okay? So just let me know by writing in the comment section that audio and video everything is perfect, and yes sir, we are ready. You can start digital electronics. We are ready to make this subject as the best subject of our engineering. Just let me know. One more thing, just mention your branch as well, because this is for all the branches: electrical, electronics, CSIT as well as instrumentation. So you can just mention your branch. Before starting the class, I just wanted to show you what is the weightage of digital electronics in the past 5-year trend. Okay, so more or less the weightage will be nearby only. Okay, so you will have a complete information what the weightage of the digital electronics for gate. Okay, if we observe last 5 year, then first of all observe for CSIT. So in CSIT, the subject name is Digital Logic, and almost 5 to 6 marks in 2025. It will be 5 marks for 2024, 6 marks for 2023. So you can average it as 4 to 6 marks weightage, and this is just a baseline. It means if you are preparing for GATE, then these marks must be obtained by you. And one very important thing is, it is very easy to score these marks. Okay. It is very easy to store this marks as well. From ECE branch, this session is live, and sir Hindi, this batch is in English only, but everything you are able to understand. Okay, I am going to use very simple language. Okay. Another thing is ECE. If you observe for ECE branch, it is around 6 marks or 4 marks in 2023, then again 22 6 marks. Almost 5 to 6 marks weightage will be there. Sometimes it increases as well. Okay. For digital electronics in EE, if we observe, it will be around some years it will be around 8 marks, and some year it will be around 2 marks. Average, it is again 5 to 6 marks have the fixed weightage. Means you are going sure short 5 to 6 marks this year as well. And these 6 marks are very important because very easy to gain these 6 marks. Is it okay? Also, it will help you in the different interviews, and if your preference is to move towards the VLSI branch or some CS core branch, then also digital is very important for all of you. Okay. If we talk about IN will have a little bit higher weightage. It is around 8 to 10 marks. Mostly the EE and ECE student also fill with IN. So the same subject with the same information you can appear with the IN as well as with the EE or ECE. Is it okay? Now let's have a discussion to the books. So there are so many authors and so many books. Need not to follow the books. You can just follow these lectures which I am starting from today now. That is sufficient for the GATE or ESC prelims exams. But if you are preparing for mains, a little bit books are also a little bit theoretical content are also needed. Is it okay? Along with some questions, some theoretical content is also needed. However, if we talk about books, then digital design, Morris Menu, that is for the ECE branch as well as CS for CSIT branch, Morris Menu by the Digital Logic and Computer Design. So these two books for ECE and CSIT. Okay, if your branch is CS, you can opt this one. If your branch is ECE or EE, you can opt this one. Is it okay? Need not to use the book. Only open the books if you want to learn more in particular topic, or if you want to explore that particular topic more, if you have a time, if you want, then only you can go to the books. Otherwise, you first go with the notes and then use the books unsolved questions. Is it okay? Or solved examples. One more book, you can use RP-Jan. This is also easy in language, as well as more number of questions will be there. You can also use Anand Kumar. Floyd is one of the favorite book, but since it's a foreign author, so there may be a language issue with the student. Sometimes a student feels some language issues. Number of questions are less, but the theory content is very good. Okay. Now let's move towards today's topic. So, are you ready to fall in love with digital electronics? Hoping all of you are ready to fall in love with digital electronics. This course is full, complete syllabus, crash course? No. This course is a full course. But yes, it's on YouTube. So, this course is little bit fast. I will cover the things in a little bit speedy way. But every topic or every content which is required for the GATE, that is going to be covered in this particular class. Okay. So what are the content in today's class we are going to discuss? First, introduction to the digital electronics, simplification of logic. Then we will move towards basic operation, Boolean theorem. Then SOP and POS expression forms. What is the use? How to form the truth table. And then lastly, if the time allows, we will move towards the switching circuit as well. So, if any question, please let me know. Some of you have a question how to make the notes of this particular class. So see, some contents are already typed. Is it okay? So those content which is already typed, I will read for you. You can leave that particular space and note down later on. Okay. Another thing is you can just listen the lecture properly. Whatever important things I am writing, that you need to write in short. Okay. And download the PDF. Go through the PDF once. That's all you have to do. And also you have to practice the PYQ question based on the topic that we are going to cover today. I will, at the end of the class, I will make a concise information to all of you. What are the content we have covered today and how you have to do the revision and do the question practice. How to prepare for the next class. Is it okay? Great. Someone is asking, sir, please reply. Already I have given. Give me, sir, can you please give us a practice questions? Yes. It is possible that I will give some practice questions to you. Okay. So, I will keep 10 questions as a practice question homework to all of you on daily basis. Is it okay? Anything else? Anyone, if anyone wants to ask anything else, because this is the first class. So if anyone want to ask anything, please feel free to ask. Sir. Okay, some people are started talking with their friends in the comment section. Great. So, sir, how to minimum number of NAND gate to implement any function? You can implement the function by using basic gate and then put the bubble at the output of AND gate and the input of OR gate. Automatically your function will get implemented. It is very easy. So we will see how to implement. It is very easy. Okay. Some portion is difficult when the number of inputs are going to be fixed, and for that there is a process that we will follow. We will take the entire bar of the expression and then we will follow that. Sir, where to download the notes? So you will get the notes onto the app, that is pw.live, and there you have to select the same batch, that is a free access batch. You will get the notes. Another is you can opt the notes through Telegram group. So my Telegram group is Varun Sir PW. You can join this group, Varun Sir PW Telegram group, where I will share the notes as well. So allow me to move for today's class. Great, sir. Thank you. Thank you, everyone. So let's start for today's class. Okay. Okay. Please see. When the first topic comes in our mind is, what is a digital electronics? What is a digital electronics and why we are so much influenced toward digital world? Why we want to digitize everything? What is the reason? What are the advantages that we want to digitize everything? Okay. So if we talk about digital electronics now, it is a combination of digital devices. It is a combination of digital devices designed to manipulate. If you want, you can just write down. It will be great if you make your notes along with me. Okay, so please write down. Okay, digital electronics. It is a combination of devices. It is a combination of devices designed to manipulate physical information or quantities that are represented in digital form. It takes discrete values only. Okay. Since it's a first class, so I just wanted to move such that everyone will be able to understand. Most of you have a question in your mind, why we want digital word. We have a physical word. If I want to switch on my light, I just go and switch on my light. Okay. So why we want digital word? What is the reason we are more and more intended towards the digital word? All of you are watching me on your mobile phones. I am far away from all of you. Yes, it's true. Whatever I am saying, my vocal cords are producing a vibration, and that vibration is in an analogous form. Ultimately, it converts it into a digital form. Okay. And then through A to D converters, it will get converted into the digital. Then it will be transmitted to your device, and you will have speakers. Then speakers will create same vibrations, and you will be able to hear my noise, my voice. Okay. Some noise are there, but it's still almost, it will be a nowadays almost perfect voice will be with you. Is it okay? Okay. However, I can increase the things. I can change little bit my voice, but almost 100% my voice and its nature is going with you. Is it okay? Yes, sir. So there are so many conversions involved, analog to digital, then it transmitted, then again digital to analog conversion is required. Sir, why you are not transmitting directly? Okay. Or sir, if we want to watch the lecture later stages also, is it possible? Yes, it is uploaded, and whenever you want, you can just have a live stream. If you want, you can have download option as well. So the first liberty that digital gives, even though they have a limitation that we need to do the conversion of analog to digital and digital to analog, but still the first thing is you can easily store the data in the digital form. Whenever you want, you can retrieve the data. It is easy. Think that you are in class 5th, 6th, and you have completed. There is in your school, if they started creating a register for every student and the school is 20-50 years old, then how much bulk size of the documentation room will become? And if they are storing on a simple computer, it can be easily accessed by anyone just by typing your name and the year of passing. Entire information of yours will be there. So it is easy to store and easy to retrieve. That inclined more towards digital word. Is it okay? Easy to store and easy to retrieve. Next is the design is easy. Design is easy. It's true? Yes, sir. Better accuracy and precision. But the better accuracy and precision is within the digital word only. If we compare it with the analog, then because of the conversion part, accuracy may loses in the conversion of A to D and D to A. Is it okay? If someone is standing just in front of me, maybe the voice is different and you are far away from me, it is converting from analog to digital and digital to analog, maybe you are feeling little bit more good sounds. Okay, why? Because there is a error possible during the conversion. Is it okay? Yes sir. And processing is easy and programmable. When we talk about programmable, it means if you have a mobile phone, if you want to store a movie, you delete that movie, you can restore some other movie. You can again delete the movie, you can restore some other movie. So there is a possibility that you can restore the data as many times as you want. You can use the same mobile phone for the gaming as well as for the phone calls, as well as for the SMS, for your WhatsApp, everything. So because the processing is programmable and reprogramming is possible, the same device can be used for the multiple purposes. Is it okay? So digital also gives, Bitaji, is everything going perfect? Just let me know by writing in the comment section or marking thumb symbol in your comment section. Okay. So easy and processing is programmable. So reprogramming is possible. It means same digital device can be used as many times as we want. So because of these, because of the easy to store, because easy to design, programmable, reprogramming is possible, we are more influenced day by day towards digital world. Is it okay? Now we are cross the digital era and move in the AI era as well. Is it okay? Yes sir. Next is power consumption is very less, and that makes the digital devices to be more and more portable. So power consumption is less, it makes the digital devices more and more portable. Fabrication of digital circuitry can be done on IC chip, hence the size and cost which matters most in the entire world. Is it okay? Size and cost matters most in the entire world, because two things we are always have a deficiency of space and cost. Is it okay? So space and money, these two things are always required. So it reduces the size as well as cost, because the digital circuitry can be fabricated on the IC chip. So because of these advantages, we always intended towards more and more towards the digital world. But there are some limitations as well. If we talk about limitation, the first limitation is every data like temperature, my voice that is in analogous form. Is it okay? Every data, temperature, pressure, velocity, every data is in the form of analogous, and we have to do the conversion of analog to digital. And again, in order to reuse in a real world, we have to do the conversion from digital to analog. So because of this conversion process, which is the most difficult and error possible in the process of conversion, there is a limitation of digital world. Is it okay? And the next is difficult to understand. Sir, digital is the most easiest subject, already you told. Yes, it's true. Digital is most lovable and the most easiest subject in your entire engineering. So why you are saying, sir, it is difficult to understand? Not by you, by the engineers. It is difficult to understand by the laymen. If I ask you what is 1 plus 1, what you say? What is 1 plus 1? What is 1 plus 1? If we have to represent with only one bit, what is 1 plus 1? Most of you say, sir, 2. It's right. But in digital, what you represent? 0, carry over 1. So if you say someone that 1 plus 1 is a 0, then first thing comes in the mind is you don't know anything. Even you don't know the numbers. But it is difficult to understand by the layman, not by the engineers. And that is why digital, though it is very cheaper, but it's still expensive, because specific engineers are needed to understand this and to implement it. But note it, now the AI can do what the basic engineers will do. Is it okay? So you have to increase your quality on daily basis. Great. Now let's move to the simplification of logic. Why we want simplification of logic? Most of you are aware with the AND logic, OR logic, and NOT logic. If you don't aware, need not to worry. Just listen me very carefully. Is it okay? Suppose if someone asked me to design, a logic circuit, which performs a function f of a comma b as a bar b plus of ab. Someone asked me to design this logic circuit. Is it okay? Where a and b are the inputs. Is it okay? Which can be a 0 or 1. Our entire digital world will have only two levels, 0 or 1, and these two levels are voltage levels. Is it okay? However, in actual practice, there is the range of low voltage level and range of high voltage level. But if we talk in a local way, that it is only low voltage 0 volt and high voltage 5 volt. Let's go in that way. So we have to represent either a high signal or a low signal. The entire digital will be designed in this way. Is it okay? Yes, sir. Now please observe. So we have to implement a function a bar b plus of ab. Let us suppose for a moment. Okay, this is a product is represented by and plus symbol is used for or. That we will see later on. Basic, if we talk about, you will able to understand. First we need one NOT gate. NOT gate is used to just invert the signal. If we have a low signal, we get a high signal. If we have a high signal, we get a low signal. Is it okay? It means if we have a low voltage level, after passing through a NOT gate, it will become high signal. A 0 volt will become 5 volt, 5 volt will become 0 volt. Simple. And we have to perform a bar b. Okay, so we have to use one AND gate. This is a AND gate. Later on stage we will see the logic gates. Presently just listen me very carefully. Okay, if you know, very good. If you don't know, need not to worry. Just listen very carefully. So we have a bar b. We have a bar for the product. Na, this AND gate is used. So we have a bar b. Next we have ab. So if I want to implement ab, I will use one more AND gate, and this will give you AB. Then an OR gate is needed to implement a bar b plus of AB. So one engineer made this logic circuit. A user asked to design a digital logic circuit which performs a bar b plus AB, a function. Is it okay? And an engineer uses to design this. Let us suppose for a moment every digital device will have some cost. Let it be 1 unit cost. So what is the total cost here? 1 unit, 2 unit, 3 unit and 4 unit. Unit means paisa, rupiah, anything. Is it okay? So we have 1 rupees, 2 rupees, 3 rupees, 4 rupees. So if we talk about each digital device will have 1 unit cost, we have 4 unit cost. Is it okay? Another thing very important is propagation delay. What is propagation delay? These digital devices are designed by electronic devices as a switch, BJT, MOSFET and so on. And any device will take some time to respond. TPD, called as propagation delay. Propagation delay is the time taken by the device to provide its output after input is being applied. Propagation delay is the time taken by the device to provide its output after input is being applied. So, in order to have the correct value of function f, how much minimum time delay we have to suffer? Here, in order to have a bar, it will take 1 propagation delay time. Let us suppose for a moment each logic gate will have a propagation delay TPD. Okay, sir. Now, this logic gate, in order to have a bar b and ab, once the data applied on the input pins a bar, b and ab both are at the input, then it would take TPD time. So from starting, if we talk about, it will be total 2 TPD time, and 1 TPD time is taken by this OR gate. Is it okay? Yes, sir. So if you want a result a bar b plus of ab, in order to implement this particular function, we need 3 propagation delay time. For a moment, suppose 1 propagation delay is 1 microsecond. So 3 microsecond is needed to process the function. If we are getting the function before 3 microsecond, maybe the function is wrong. So we need some hardware interrupt, and that hardware interrupt keep the output blocked until unless desired function will be available at the output. Is it okay? So the total cost will be of 1, 2, 3, 4 unit, and the time taken will be 3 propagation delay. Now this problem will first addressed by the Boole in 1854. He discovered a basic algebra to minimize the logical expression. Now if you observe, can I represent the same function AB as A bar B plus of AB? What is common in both of them? So if you observe, result B is common in both of them. Is it okay? So we can take B common. So this will become A plus A bar. Soon we will see what is A plus A bar. Presently I am just writing. A plus A bar is just 1. So B into 1 will become B only. Some other engineer uses this Boolean algebra to minimize the logical expression, and now he want to implement the circuit. So he made the circuit like this. Okay. He made the circuit like this. A, B, output Y. What is the cost of the circuit? 0. What is the delay in the circuit? 0. So the circuit is faster as well as lesser in cost. How many of you now able to understand why we want to minimize the logical expression before implementing any logical device? How many of you? Beta ji, I am using very simple language. You can just, it's a very simple language because this is on English channel. How could I go with the Hindi? But I am using very basic language. You can easily understand, just focus. How many of you now able to understand that output is implemented the same function with a 0 cost and much faster comparative to this circuit? So always remember, before implementing any function, we must need to minimize the logical expression. We must need to minimize the logical expression. This reduces the cost of the circuitry and increases the speed of operation. Is it okay? How many of you now able to understand? Great. So now you know what is the purpose of minimization of logical expression. Those who don't know about A plus A bar need not to worry. In today's class only we are going to discuss everything. Okay. This is just to make you understand what is the purpose we are using minimization. Is it okay? Now we have 3 ways to minimize any logical expression. We have 3 ways to minimize any logical expression. Simplification or minimization of logical expression. Please write down. Simplification or minimization of logical expression. Great. Now please observe. First is Boolean algebra. Boole in 1854 discovered an algebra for minimization of logical expression. Boole in 1854 discovered an algebra for minimization of logical expression. It is generally used when the number of variables are up to 3. I am not saying its limitation is up to 3. You can use for any number of variables, but it is useful for our purpose. Our purpose is to solve the question fastly in GATE, okay, or engineering services examination. Okay, so generally it is used up to 3 variables. Beyond 3 variables, this Boolean algebra will become little bit complex, and its result, since the minimized result is not unique, so there is very difficulty to go with a Boolean algebra more than 3 variables. Is it okay? So up to 3 variables, Boolean algebra is good. Please write down. It is generally used up to 3 variables. It is useful only when the outputs are 0 or 1. It is useful only when the outputs are 0 or 1. Next is K-map, Carnot map. Next is Carnot map. Great. So if we talk about Carnot map, It is used up to 5 variables. Can we use for 6 variable? Yes. Can we use for more than 6 variable? Yes. But useful for 5 variables, because beyond 5 variables, the complexities of reduction through K-map increases. Is it okay? So up to 5 variables, we can use K-map. In K-map, outputs, when we are using K-map for minimization, outputs may be 0, 1 or don't care. There is one more output possible called don't care. Like you don't care about your result. Don't care about the result. So in the same way, there is one output for which we can say don't care about the output. Okay. So the output can be 0, 1 or don't care. Next is tabulation method. Tabulation method can be used for any number of variables. Tabulation method can be used for any number of variables. Tabulation method can be used for any number of variables. Means for more than 5 variables, we will prefer to go with the tabulation method. More than 5 variables, we will prefer to go with the tabulation method. Is it okay? Great. Now, let's talk about basic operation. So, previously I said to you that the entire digital word will be designed only in 0 and 1. This 0 and 1 is nothing but voltage levels. So the entire digital word will be designed only in 2 levels. The entire digital word is designed only in 2 levels. One level is 0, you can say low level, or one level is high, you can say 1 level. Is it okay? So the entire digital word works only on these 2 levels, either low or high. Is it okay? Yes, sir. Now let's talk about basic operation. Basic operation means what we can do with the 2 level voltages. What we can do with the 2 level voltages. Is it okay? That is going to decide the entire digital word. Now please observe, first one is your NOT operation. First one is your NOT operation. Okay. So if we have only 2 level possible, and if we have a level low, what we can do? We can either keep the level as it is, or we can invert the level. Okay. So yes, sir. So NOT operation means if we have low level, then after performing NOT operation, the level will become high. And if we have high level, then after performing NOT operation, level will become low. In terms of variables, if we talk about in terms of variable, I am just saying variable means a input. Okay, suppose if we have a signal A, it means a input signal. It can be a low or high. A can be a low or high. If we have a variable A, I am just giving a liberty, you can choose whether the input is high or low. So A may be high or low. If we perform NOT operation, so what happened? If A is high, it will become low. If A is high, then it will become A bar. If A is low, then it will become high. High is represented as complement. So the level get complemented. Is it okay? Yes, sir. If we have A bar and we perform NOT operation, where A can be 0 or 1, if A is 0, then its complement will be, yes, beta ji. If A is 0, then its complement will be 1. Yes, sir. And 1 NOT operation will become 0. So A bar will become A only. A bar will become A only. So even if you present at that particular era of 1854, you will also give the logic in the same way. We have 2 possibilities. So if we have 0, we may make high. If we have high, we make low. Is it okay? Yes, sir. The other basic operation is AND operation. So in AND operation, we have given priority to the low signal. Suppose if we have 2 signals, so we can give priority to one of the two signal. Is it okay? So if we have two signal, we can give priority. In AND operation, we give priority to low. We give priority to 0. So it means if we have 0.0, what it would become? 0 only, but priority is 0. Dot is the symbolic representation of an AND operation. Is it okay? Then 0 into 1. 0, 1. What happened? Sir, if one signal is low and one signal is high, priority is given to the low signal, then it will become 0 only. If we have 1, 0, then also 0 only. If we have 1, 1, then if both the signals are high, then it will become 1. And that is why we are representing in a product form. How many of you able to understand it? Great. Is it okay? How many of you able to understand up to this part? Great, sir. Now, please observe, if we talk about next in terms of variables. Let us suppose we have a two signal and I am representing the variables W, X, A, B, anything. Okay. So I am using variable A, B. So suppose if we have a variable A, so variable A dot A, what it happens? What is A? A may be 0, maybe 1. A may be 0 or maybe 1. If A is 0, if A is 0, then this will be 0.0, we will get 0. If A is 1, we will get 1.1, 1. It means A dot A will give you A only. A dot A will give you A only. Is it okay? Yes, sir. The result is same as A. If we have A dot 0, then priority is of 0. Irrespective of A, we have 0 only. If we have A dot 1, then what happened? Now the priority is of 0. We have to check A. Here this A may be 0 or maybe 1. If A is 0, we get 0. If A is 1, we get 1. It means A into 1 is the same as A only. A into 1 is the same as A only. If we talk about A dot A bar, here A may be 0, may be 1. If A is 1, A bar is 0. If A is 0, A bar is 1. So this is the product of either 1, 0 or 0, 1. And we all know in AND operation, priority is given to low signal. So definitely this A into A bar, we will get 0 only. Is it okay? How many of you able to understand, beta ji? Please let me know by writing the comment section. Great. Let's move to the next operation. The entire digital world is designed by three basic operations. We have a signal either low or high, or another thing, we have a possibility of two signals coming, so we can give priority to any one of them. So in AND operation, we have given the priority to 0. So in OR operation, we give priority to. In OR operation, we give priority to. In OR operation, we give priority to. If we talk about OR operation, then in OR operation, we give priority to. Sir, in AND operation, priority is given to 0. So in OR operation, we have given priority to logic level 1. Priority to logic level 1. How many of you able to understand, beta ji? Great. Now please observe, if we have 0, 0, if both the signals are low, then output is low only. If any one of the input signal is high, then what is the output? If any one of the input signal is high, then what is the output? Output is logic level 1. Priority is given to logic level 1. That is all you can do with only two possibility of low and high. Either you can invert NOT operation. Among the two inputs, you can give priority to either low or high. So AND or OR operation. Your entire digital world will be constructed by these three basic operations only. How many of you able to understand? Great. How many of you able to understand up to this part, beta ji? Great. In terms of variables, if we talk about in terms of variables, so if we have a variable A, then what is a plus a? A may be 0, may be 1. A may be 0, may be 1. If we talk about 0 plus 0, we get 0. If we talk about a is 1, 1 plus 1, we get 1. So a plus a is a only. A plus a is a only. If we talk about a plus 0, then a may be 0, may be 1. A may be 0, may be 1. If a is 0, if a is 1, we get 1. If a is 0, we get 0. Is it okay? So a plus 0. A may be 1, may be 0. If a is 0, we get 0. If a is 1, we get 1. So it means a plus 0 is same as a. If we talk about a plus 1, then priority is high signal. So if 1, you will get 1 only. So 1 plus anything is 1. This plus is a symbolic representation of OR operation. And the OR operation is not an addition. OR operation is showing that priority is given to a high signal. Now, if we talk about a plus a bar, what happened? What is a plus a bar? What is a plus a bar? A may be 0, may be 1. So you are talking, sir, about 1 plus 0 or 0 plus 1. If a is 0, then 0 plus 1. If a is 1, then 1 plus 0. So it is always either 1 plus 0 or 0 plus 1. So what we will get? 1 only. How many of you able to understand, beta ji? So your entire digital word will be created by these three basic operations only. Is it okay? Great. Now let's move to the simplification of logical expression. Is it okay? Now please observe. Please write down a question format. Find the minimized expression for the functions shown below. I am using the same question for the different functions. Okay. I'm just going to write 1, 2, 3, so on. So please observe. Suppose if we have a first function I am writing. Suppose if we have a function f of a comma b as a b bar plus of a b, then what will be the minimized expression for this function? We have a b bar plus of a b. So what will be the minimized expression for this function? Now please observe, can we take a common between them? Yes, sir. A is one result and b is one result and b bar is another result. Is it okay? Because b bar may be 0 or 1 depending upon b. Now please observe, here we can take a common. We can take a common. So if you take a common, what will be remaining? B plus b bar plus b. Can I write in this way? Yes, sir. We have already seen a OR operation. Variable plus variable complement is always equals to 1. So we have variable plus variable complement. That is going to be 1 only. A into 1 is same as a only. So we have a minimized expression for the function a bar b plus of ab as a only. How many of you able to understand this? Great. Instead of implementing this function, it will be far better to go with this function. Is it okay? Yes, sir. Now please observe once more. Let's have another question. Suppose we have a function ab as a bar b plus ab bar plus ab. What will be the minimized expression for this function? Now please observe. First we have learned to take common. Hoping all of you able to understand how to take common. Yes. Now please observe the second. Here we have a bar b plus a b bar plus of ab. Now can you please tell me what is a plus a? Can you please tell me what is a plus a? What is a plus a? I'm just using a rough part. This is just a rough part. I'm using just a rough part. Can you please tell me what is a plus a? A plus a is a only. Absolutely right. What is a plus a plus a? Again a only. It doesn't matter how many times you will going to write a plus a plus a plus a. If a is high, you will get a. If you will get 1. If a is low, you will get 0. Is it okay? Same as a only. Suppose if we have a ab plus ab. So what we will write? ab plus ab. ab is a result. When we do the product of ab, either we will get 0 or 1. Result ab will either give 0 or 1. So ab plus ab will give you ab only. AB plus AB will give you AB only. If I write AB plus AB plus AB, then also you will get result AB only? It doesn't matter how many times you are going to write. Yes, sir. Now please observe here. Can I represent this AB as A bar B plus of, I am just representing this AB plus AB bar plus, again I am writing AB. Can I represent like this? I can write one AB in the expression as many times as I want, as plus AB plus AB plus AB plus AB and so on. Yes, sir. There is no limitation for this. It will again AB only. So you can write AB as AB plus AB. Now, is there anything common between first and second? Yes, sir. What is common? B is common. So this will become A plus A bar. And is there anything common between second and third? Yes, third and fourth. Yes, sir. A is common. What it will become? B bar plus B. We all know variable plus variable complement is equals to 1, and variable into 1 is same as variable. So what we are getting? Either you can say B plus A or A plus B. Someone can write A plus B. Both are the same thing, because the result of B plus A or A plus B will remain same only. How many of you able to understand, beta ji? So here we have learned we can take common from the same minterm as many times as we want. How many of you able to understand? We can take common from the same minterm as many times as we want. Actually, this is a minterm. Later on we will see. How many of you now able to understand? Great. Let's have one more question. Can you find the minimized expression for the third function? I am writing A, B, C as A, B bar C plus A, B, C bar plus A bar, B, C plus A, B, C. Can you find the minimized expression for this function? Can you find the minimized expression for this function? Let's try. Sir, is there anything common between first and last? Because there is only one complement. AC is common. Is there anything common between second and last? Yes, sir. We can see AB is common. Is there anything common between last two? Yes, sir. BC is common. You can write ABC plus ABC plus ABC. That is nothing but ABC only. Isn't it? Yes, sir. So we can take common from the same minterm as many times as we want. Now this will help you lot to solve the problems. Please observe here. We can write ABC plus ABC bar, ABC plus A bar BC plus ABC. Can I write like this? How many of you are able to understand? Please let me know by writing in the comment section, beta ji. Yes, sir. Among them, AC is common. AC is common, and we all can see B plus B bar reduces to logic level 1 only. B plus B bar is reduces to logic level 1 only. Here we have AB common. C plus C bar reduces to logic 1 only. Here we have BC common. So A plus A bar reduces to logic level 1 only. So we all can see the minimized expression AC plus AB plus BC. This is the minimized expression of the given function, as well as this is the a self-dual expression and the output carry output expression of a full adder. All these topics we will see later on. How many of you able to understand up to this part? Please let me know by writing in the comment section, beta ji. Great. Now let's move to the next part. So we have learned up to about two things. First, to take common. Now you know how to take common. It doesn't matter how long the expression will be. Second, you have learned we can take common from the same minterm as many times as we want. Third, let's talk about one more question. Suppose you have to identify the minimized expression for the function. Suppose you have to identify the minimized expression for the function AB plus A bar B. Okay. Suppose you have to identify the minimized expression for the function, SOP minimized expression for the function. Okay. So how to find the minimized expression for this function? You will open the bracket. How to open the bracket? First term will be multiplied by the first term will be multiplied by the second term will be multiplied by the first term, second term will be multiplied by the second term. Usual, all of you are knowing about the how to open the brackets. So I'm using the same. So how to do that? A dot A bar, first term with the first term, plus A dot B, first term with the second term, plus B dot A bar, second term with the first term, plus B dot B. Can I write like this? Yes sir, you can write. Next, sir, we are able to find out the the common. What is common? Sir, if we observe 1, 2, 3, these three, if we see, this A into A bar is 0 only, because we all know A into A bar is 0 only. Variable into variable complement is always 0, because if variable is high, its complement is low, and the product of the two will always give 0 only. Is it okay? Because priority in AND is 0. So A into A bar is 0 only. Here we can take B common. Yes sir. And if we take B common, then what happened? Sir, basically B dot B can be represented as B only. Basically B dot B can be represented as B only. Let me show you once again. B dot A bar plus B dot B dot B dot B is B only. Can I take B common? Yes sir, you can take B common. If I take B common, then remaining result will be A plus A bar plus 1. We all know 1 plus anything is 1 only. Yes sir, and 1 plus anything is 1 only. So B dot 1 will give you B only. The minimized expression for the function is B only. How many of you able to understand this? Yes. But sir, it's a very lengthy process. For two brackets, okay, it is good. But what happened in case if there are many terms? Can we open all the terms? It will take lot of time. Is there any shortcut? Yes. Please observe, we can do this in a single line. How to do that? Please observe. Whenever you have to open the brackets, first find out the same result in the two brackets. A and A bar are the different result. However, B and B is same result. Same result means either it will give 0 or it will give 1. So B and B both are same. However, A and A are two different literals. Same variable, two different literals. B is a same variable and same literal. Is it okay? So you have to identify the same result. Then multiply same result plus multiply different result. Just you have to do that. So B plus B dot B will be represented as B plus A bar will become 0. So your answer is B. How many of you able to understand? Whenever you have to open the brackets, you can use this theorem. This theorem is called transposition theorem. Let's talk about transposition theorem now. Let's talk about transposition theorem now. How many of you now able to understand up to this part? Great, sir. So transposition theorem. What transposition theorem says? Transposition theorem, we are not going with the all definitions and all. I'm just keeping it very simple. How to use that particular theorem. Okay. So transposition theorem. Suppose if we have a plus B and we have a B plus C. Okay. So what transposition theorem says? If you have to open this, you can just multiply the same result in the two brackets and multiply the different result in the two brackets. So plus B plus AC. It's very simple. How many of you now able to understand the transposition theorem? Let's utilize the transposition theorem to minimize the logical expression. Suppose you have to find the minimized logical expression of the function. This. Let me show you. Find the minimized logical expression for the function. Now these basic Boolean algebra is now in class 12th, I know. So most of you have already, even if someone is from the first year, able to understand this. Is it okay? It is very simple. Now please observe, you have to find the minimized expression for the function. Now please observe, today only you are going to learn the entire digital. And it's my promise. All other classes just a replication, run of what we are going to learn today. Okay, please observe. Find the minimized logical expression for the function. Suppose we have a function a plus b bar. Suppose we have a function a plus b, a bar plus b let me make little bit bigger. Suppose we have a function a plus b plus c, a plus b bar plus c, a bar plus b plus c, a bar plus b bar plus c. Suppose we have this function, it's a little bit bigger function. Can you find the minimized expression for this function? Can you find the minimized expression for this function? Now we know about the transposition theorem. You have to utilize that information of transposition theorem to solve the minimized expression. Can you do that? Let's observe. Observe the first and second. Or you can, if you want, you can start anyway, but I'm just using first and second. Is there any two result which is common? Yes, sir. A plus C, A plus C. We all know that A plus C will give either 0 or 1. A plus C is the expression which gives a result either 0 or 1. So in these two, A plus C is the same. A plus C is same. In these two, A plus C is the same. In these two, A plus C is same. So multiply same plus multiply different. So when we open these two, what happened? Multiply same plus multiply different. Same is A plus C and different is B plus B dot B bar. So this we have solved. Now come to this one. A bar plus C is the same result which we are able to see in both the brackets. A bar plus C will give one result, either 0 or 1. So A bar plus C is a result which is either 0 or 1. A bar plus C, A bar plus C. Multiply same result plus multiply different result. So what is the same result we have? We have same result, sir. We have same result, sir. A bar plus C. And we have different result, sir. B dot B bar. So we all know B dot B bar will be reduces to 0 only because variable plus variable complement will reduces to 0 only. So this will become, sir, B plus B, B dot B bar 0, B dot B dot B bar 0, A plus C dot A bar plus C. Can you open A plus C and A dot A bar dot C? Yes, sir. Now again, C is the same result. Multiply same result plus multiply different result. So this will become C plus A dot A bar. We all know A dot A bar is reduces to 0. So your minimized answer is C only. How many of you now able to understand up to this part? How many of you now able to understand up to this part? Please let me know by writing in the comment section, beta ji. Please let me know by writing in the comment section, beta ji. How many of you able to understand up to this part? Great. Great, great. So now I am hoping all of you able to understand how to use the transposition theorem. Now all of you know how to use the transposition theorem. Great, sir. Now please come to the one more question. Or just I am skipping this, directly showing you the theorem. Okay. Next, please come to the distribution theorem. It is just opposite to transposition theorem. Opposite to transposition theorem. How many of you able to understand distribution theorem? Just let me know. No, sir. Okay, let's have a discussion on distribution theorem. Suppose we have a function f of a comma b comma c as a plus of bc. Okay, so can I write this expression by considering this as by considering this as literal 1, literal 2, literal 3 and writing 1 plus 2 literal and 1 plus 3 literal. Can I write like this? Yes, sir. What happened then? It will become A plus B, A plus C. So it is just opposite to the transposition theorem. It is just opposite to the transposition theorem. Now please observe. Can you find the minimized expression for the function? Find minimized expression for the function below. Now please observe, beta ji. If we have a function, let us suppose f of a comma b. I am moving little bit faster. I am increasing a speed little bit, but hoping all of you can easily adjust with the speed. Okay. If anyone will feel any kind of difficulty, need to write in the comment section. I will love to hear whatever you want to ask. Okay. Okay. And don't write by and everything. Okay. So, okay. Now let's come back to the class only, because I just want to utilize more and more time in your studies. Please observe here. So what is a plus a dot b? A dot b, suppose if we have a function a, b and a, b. Okay, let me show you with the two variables. So suppose if we have a bar b plus of a bar b plus of b bar. Suppose we have a function a bar b plus of b bar. Can we do the minimization of this function? Yes. How, sir? Please observe. If I am able to see here b bar and b, the first thing comes in my mind, if it is possible to write b plus b bar, that reduces to logic level 1. Yes. So can I use a distribution theorem here with considering this as 1, 2 and 3? So can I write 1 plus 2 and 1 plus 3? Yes, sir. What it would become? Sir, this will become b bar plus a bar and b bar plus b. What is b plus b? B bar plus b, logic level 1. So we are getting b bar plus a bar. This will be logic level 1. That is, finally we are getting an answer as a minimized expression for this is b bar plus a bar. How many of you now able to understand the transposition theorem as well? Great. I am moving little bit faster, but hoping all of you can easily able to understand. Sir, could you please explain by the numbers? I am using by the numbers only, na? Sir, please clear my confusion. Is there any course we should learn in BTech ECE that can help to get 30 to 40% in MTech VLSI? Yes. Digital electronics and your analog is a most important part if you want to move in the VLSI. Okay. We will see the VLSI as well after finite state machines. Okay. So, how many of you able to understand up to this part, beta ji? Great. Now please observe a bar plus b bar, a bar plus b bar. Can all of you able to understand this? Great, sir. Now, please observe. Suppose we have to find the minimized expression. I am writing every question for the same. Find the minimized expression for the function f of a comma b comma c as a bar b plus of a bar b plus of ac plus of bc. Can you find the minimized expression for this function? Sir, we will try. Okay. How would we can try? Before going to this, let's have one more important. Before going to this question, let's have one more important information. Suppose if we have a expression a bar a plus of a bar b. Suppose we have a expression a plus of a bar b. Whether this expression is a minimized expression or a standard expression called canonical expression. Sir, this expression is an intermediate expression, neither a minimal expression nor a canonical expression. Any expression can be understood in two ways. One is called as a canonical expression, another one is called as a minimal expression. Okay, so if we talk about minimal expression, then minimal expression for this intermediate expression will become a plus of a bar b can be represented as a plus a bar by using distribution theorem a plus b. So your minimized expression will become a plus b only. So if you want to implement any desired function, you must need to implement the minimized expression. Okay, we will not going with the intermediate or a canonical. The other is to understand what actual function it is. That is called as canonical expression or a standard expression form. What is a canonical expression form? Canonical expression form means each product term must contain all variables. Each product term must contain all variables. Also called as a standard form. This is also called as a standard form. So if we have a plus of a bar b, we can easily identify we have two variables. One is a, another one is b. Here this product term will have two variables, but here only one variable a is there. So one variable is missing. So can I write this a as a dot 1? The answer will remain same. Yes, sir. Can I replace this one with b plus b bar? Yes, sir. And if you replace this one by b plus b bar, what happened? It will become ab plus ab bar plus a bar b. This is what we call canonical expression. In canonical expression, each product term contains all variables. Actual function which we want to implement is this. And while implementing, our circuit must implement a plus b. So standard is representing all minterms. Standard form will represent all minterms. Is it okay? And a minimal means a minimized expression. How many of you now able to understand, beta ji? Great. So now we know about the canonical and minimal. If we have an intermediate expression, we know to identify the canonical as well as minimal form. Is it okay? Yes, sir. Mostly this is used in multiplexer because multiplexers gives the output in an intermediate form. Okay. So always remember that any expression can either be represented in a minimal or in canonical. Canonical will give us an idea about what actual function is going to be implemented, and minimal must need it to implement a function with increasing the speed and minimize the cost of circuitry. Is it okay? Great, sir. Now let's move to the question. Suppose we have to find the minimized expression for the function shown below. Find the minimized expression for the function shown below. Find the minimized expression for the function shown below. Find the minimized expression for the function shown below. Let's talk about this. Wait, beta ji, why you are saying good night? Wait for a little bit more, okay? Let me complete the class of 2 hours, okay? So please let me complete what I said now. Today only you will be able to understand the entire digital and the purpose of digital, okay? So just let me complete it. Now please observe, beta ji. Find the minimized expression for the function shown below. Suppose we have a function f of a comma b comma c as a bar bc plus of a bar b plus of a c plus of bc. Can you find the minimized expression? Can you find the minimized expression? Yes, sir, we can. How to find the minimized expression, sir? What we do, we multiply with 1 because we have a total number of variables. 3, A, B, C. But in every product term, we are able to see only 2 variables. So one variable is missing. So we can put 1 here and put C plus C bar. We can put 1 here and make B plus B bar. We can put 1 here and make A plus A bar. And then we can expand. We will start taking the commons. Even if you do that, you will reach to the same place. Yes. Bhai, wait. Whenever you feel sleepy na, just stand up. Okay. Take a long breath and then again sit back. Now please observe. It's magic. Please observe here. We have A bar B plus of AC plus of BC. So how to find the minimized expression for this? Now please observe beta ji. Can I write this expression as A bar B plus AC plus BC into 1? If I write in this way, is anything get changed? No sir, you can absolutely write this. Can I replace this one? Can I replace this one as A bar B plus of AC plus of BC, A bar B as A plus A bar? Can I write like this? Yes sir, you can write like this. Okay. So your expression will become A bar B plus AC plus ABC plus A bar BC. Okay sir. Is there anything common between first and last? Is there anything common between first and last? A bar B seems to be common, sir. Is there anything common between second and third? AC seems to be common, sir. So if we take A bar B common between first and last, the remaining portion will be 1 plus B, 1 plus C. Okay. Yes, sir. 1 plus C will remaining. And if we take AC common, then we have remaining, sir, 1 plus B. We all know anything plus 1 is 1 only, because anything plus 1 is 1 only because plus represents OR operator, and whenever OR operation performs, the priority is given to logic level 1. So anything plus 1 is 1 only, sir. So here we can say, sir, this will be A bar B plus of AC. Oh, great. It can't be further minimized. So we have the answer, sir. We have the answer, sir, the minimized expression for this particular function. But sir, you already said if we use to multiply 1 in each of the minterm and then try to solve, we will not reach to this result. Why it is so? Because if you do that one multiplication, you will take common, you will again reach back to the same result. Sir, if I multiply this one instead of this here, then what happened? You will not reach to the conclusion. This question is asked in engineering services conventional exam, this kind of question 2 to 3 times, and you have to explain, you have to write the minimized expression for the given function. Okay, expand the function to the minimized expression in like that. Okay, so if you multiply 1 here, you will not reach to this result. If you multiply here and put C plus C bar, you will not reach to this result. So sir, how would you know that only 1 need to be multiplied here? Because I know the answer, sir. Sir, you know the answer. Yes, I know the answer because answer is within the question itself. I know because I can see the answer within the question itself. Sir, how would you able to understand this? That answer is within the question. With the help of consensus theorem. In order to avoid static and dynamic hazards, we intentionally use some redundant terms. And the way which we are using to introduce the redundant term, in the same way we can detect the redundant term as well. Redundant term is not necessary. Redundant term is not necessary. Is it okay? So I am able to identify the redundant term. And if I am able to identify the redundant term, I know about the answer. Sir, which theorem you are talking about? This theorem is called as consensus or redundant theorem. Please write down. Consensus or redundant theorem. Consensus or redundant theorem. It is very easy to identify the redundant term, and it is applicable to both SOP as well as POS. We will later on see what is SOP and what is POS. Just write down consensus theorem now. Write down consensus theorem. Consensus theorem is also called as redundant or redundancy theorem. The purpose of using this theorem is to identify the redundant term. Redundant means not necessary term, which is not required or not necessary. We intentionally use that to avoid static hazards, in some cases dynamic hazards too. Is it okay? Yes, sir. Now let's talk about consensus theorem. Consensus theorem is applicable. Consensus theorem is applicable. There is some rule how to use. So first is consensus theorem is applicable when expression must be of three variables. So if you want to identify the redundant term, first of all you have to observe beta 9 to 11. The class timing is abhi 07.70. 007 is okay. What does it mean 07.70? Okay, it means you are going to be 100 times of your own version. Great. So 100 times of your own version. Great. Now please see, the class timing is from 9 to 11. 2 hours of class I have kept, because then only we will be able to cover in the allotted classes. Okay, I just don't want anything to be missed by anyone. Okay, now please observe, expression must be of three variables. Each expression or each variable must be twice in the expression. Each variable must be twice in the expression. Each variable must be twice in the expression. It's all about, it all depends upon the way of vision, na? Munish is saying, sir, it's a birth time. No, it's all depends upon the way of vision. What I see, that Abhi wants to become 100 times of his own version. So 100 or 1000 times of his own version. Okay, so accordingly I just told you. Great. Now please see. Next is, each variable must be twice in the expression. Next is, only one variable is complemented or uncomplemented one. Only one variable is complemented or uncomplemented one. In brackets you can just write and the minimized expression is related to complemented or uncomplemented one. And the minimized expression is related to complemented or uncomplemented one. Let's try to understand. Please observe here. Suppose you have a function, a comma b comma c as a b plus b bar c plus a c, and you have to find the minimized expression for this function. So when I see this function, first thing comes in my mind, whether the consensus theorem is applicable or not. Will I be able to use? For that, expression must be of three variables. Yes, sir, this expression will have a, b, c, three variables. W, x, y, three variables. Any three variables. So this expression will have three variables. Each variable must be twice in the expression. A is 2 times, b is 2 times, c is 2 times. Each variable must be twice in the expression. I will be able to see, sir. Each variable is twice in the expression. A is 2 times in the expression. B is 2 times in the expression. C is 2 times in the expression. Yes, sir. Consensus theorem is applicable. Consensus theorem is applicable. Consensus theorem is applicable. Now, what consensus theorem says? Only one variable is complemented or uncomplemented. We can see that only b bar is complemented. We can see only b variable is complemented and all other variables are uncomplemented. So your answer is related to the complemented or uncomplimented one. Minimized expression is related to the odd one. Which is odd? B bar is odd. You have to identify the other b in the expression. That's all your answer. This will become a redundant term. How many of you able to understand? Please let me know by writing in the comment section, beta ji. We have AB plus B bar C. This will become redundant. How many of you able to understand? Please let me know. Haji. Oh, thank you, beta ji. How many of you now able to understand? Great, sir. So if we have three variables, A, B, B, C, C, A, each variables are twice in the expression. Only one variable is complemented or uncomplemented. We know about the answer. Can you tell me what is the answer for this? Can you tell me what is the answer for this? If we have a function w, x, y, and the function is w, x bar, or say wx plus x, y bar plus wy. Can you tell me what will be the minimized expression for this? Which is a redundant term? Can you tell me about the redundant term? Can you tell me about the redundant term? Sir, the expression will have 3 variables w, x, y. Each variables are twice in the expression. Only one variable is complemented or uncomplemented. So there is only one variable y is complemented. Your answer is related to the other y. And this will become, wx will become redundant, sir. This is not necessary. So your answer is xy bar plus wy. How many of you now able to understand this redundancy theorem? Whenever you have to prove this theorem, always multiply 1 in the redundant term. Then only you will reach to this. If you have to perform somewhere a proof, is it okay? For GATE it is not required, but for engineering services, maybe for the conventional part you can do. Is it okay? Great. Now how many of you able to understand, beta ji? Can you find out the minimized expression of w x y as w bar x bar w bar w y plus y bar plus x bar y bar? Can you find the minimized expression or the redundant term in this? Yes, sir. How to identify? Sir, we have 3 variables in the expression. It is only valid when it meets these 3 conditions. Only 3 variable condition, 3 variable. How to utilize this theorem? I'm just interested to utilize this theorem. Okay. And all if and buts are already eliminated. Okay. So variable, 3 variables, only 3 variables. Each variable is twice in the expression, and only one variable is uncomplemented one. So your answer is related to the odd one, that is w is only uncomplemented. So this will become redundant. How many of you now able to understand the redundancy theorem as well? Almost all are the Telugu peoples here. Great, beta ji. Every language peoples are there. Okay. And all of you are now going to enjoy this subject. Hoping all of you able to understand up to this part. Now let's talk about De Morgan's law. How many of you able to understand up to this part? Please let me know by writing in the comment section. How many of you able to understand up to this part? Please let me know by writing in the comment section. So what De Morgan's law says, if we have a bar, if we have a plus b plus c, if we have a plus b plus c whole complement, then it can have a same result as a complement plus b complement plus c complement. If we have a plus b plus c whole complement, then it is same as, oh, I made a mistake here. This is same as a complement dot b complement dot c complement. If we have a dot b dot c whole complement, it can be represented as a complement plus b complement plus c complement. So we have 2 laws for the De Morgan. De Morgan first law says, if we have a plus b plus c whole complement, it can be represented. We can just split this entire complement into the smaller result, but for that plus changes with a dot. Is it okay? Whenever the entire bar breaks, then the symbol here is replaced, dot replaced by plus and plus replaced by dot. How many of you now able to understand? Yeah, great. Majorities of all are from Telugu. Great. How many of you now able to understand the De Morgan's law as well? Great. Is it okay? Okay, great. Now let's move to the one question. This question asked in CS branch. Okay, 2 marks. It's a GATE PYQ question. GATE PYQ question. This question is asked in CS branch, 2 marks. GATE PYQ question. Let's just start with this one. Okay. Hello, beta ji. Just do one thing. You can please mention your in which year you are in the comment section. It will be great help for me as well as my team to rectify how many of you in which year, and accordingly I can just shape out the upcoming lectures. Okay. Please mention your engineering year as well in the comment section. Okay. Now branch and engineering year. Now please observe here. What is the function we have given? Function is given p plus q bar. Great, sir. Another thing is p q bar plus p r dot p bar r bar plus q bar. Okay. Which theorem we can use? The best to open the brackets are transposition theorem. So can I use transposition theorem? Yes, you can use transposition theorem. In transposition theorem, we multiply the same result plus multiply the different result. Can you see the first and last brackets? Q bar seems to be same result, and this will be different. Yes, sir. So what happened if you are going to multiply Q bar with Q bar plus what happened if you are going to multiply P bar R bar with P? It will become P dot P bar. P dot P bar will become 0 irrespective of the value of R. So by solving these two brackets, we are only getting Q bar. How many of you able to understand? See how easy it is to score these 2 marks if you know about the theorems and know how to utilize the theorem. Now what happened, sir? Nothing seems to be common. If maximum you can take P common, but the answers are little bit different. So what we can further do? Open this bracket. If we open this bracket, this will become P Q bar plus P Q bar R. What is P Q bar dot Q bar dot Q bar dot Q bar dot Q bar? P Q bar only. So it doesn't matter how many times you are going to write Q bar dot Q bar dot Q bar dot Q bar. It will be Q bar only. And what is this? PQ bar R. Can I take common PQ bar? Great, sir. 1 plus R. Anything plus 1 is 1 only. What is the result? PQ bar. Now you are able to get 2 marks. Also now you will be able to understand. Great. First year, third year ECE. Entering in third year ECE, sir. Hi beta ji. First year. Great. So those who are in first year, are you able to understand today's class? I haven't discussed about the binary number system. It started with the number system because I know that topic little bit you have an idea from class 12th. So I just don't want this crispness of this lecture to be dyed in the number system. Is it okay? However, I will discuss the number system in the upcoming lectures. Great. First year ECE, third year ECE, second year. Great. Those who are going to watch the lecture in the recorded format now, I just wanted to from them as well, you must need to mention your year of BTech in the comment section so that I can shape the upcoming classes accordingly. Okay, great. Second year, great. Now up to this part everything is clear? Great, sir. So this 2 marks question, very easy to get these 2 marks question. Can you solve this one? How many of you can solve this one? How many of you can solve this one? Just write your answer in the comment section directly. You need not to even put your pen on. Can you answer this? Kerala, great. Little, sir. No issue, beta. If you are able to understand little also, na, that's sufficient because some of the things are coming ahead and you can easily patch up the entire thing. Okay. Just believe on me, be with me and try to make your notes. Okay. Because you are in first year, so you need a little bit pressure because you first time you are having these kind of words. Okay, first time you will be able to understand these words. Those who are in third year, they know very well. During their BTech, they have suffered a lot why the minimization is needed, which now everyone knows. Okay, great. So what is the function? Sir, we can use distribution theorem. We can treat it as 1, 2, 3. So 1 plus 2, 1 plus 3, 1 plus 2, 1 plus 3. How many of you now able to understand x plus x bar and we have x plus y? Even you need not to put your pen. This is 1 dot x plus y. So your answer will become x plus y only. You won't believe this is also a gate question. So x plus y, this is not x dot y. This is not x dot y, beta ji. Not B, it's a. From Andhra Pradesh, from Kerala. Great. So it looks like entire India is now in the class. Kerala is also there, Tamil Nadu is also there, Andhra Pradesh is also the very big states, and I have visited many places as well. Most of my time is in Bangalore, so I have visited almost the entire south portion in a very well manner. And my most favorite place is Udupi in Karnataka. From Telangana, sir. Great. Great. So all these regions I have traveled. Okay. Great. Great. Now let's move to the SOP and POS. This is the most important part, and I can conclude today's class as well with this one. From Nepal. Great. Someone is from Nepal also. Great. Delhi. Tirupati, sir. I have visited Tirupati and I did Shivani Darshan. I got an opportunity to have Shivani Darshan. It's one of the finest darshan in Tirupati. Okay. So I have enjoyed a lot. That is really one of the favorite place. Spirituality, if we talk about spiritually, then I have many places. Tirupati is one of the very memoric for me, and it's a great experience. Okay. And for of course, for the living style pattern, I can say Udupi and Mangalore is the best. Yeah, great. Great. So let's have a सर गेट 2027 का बता दो. Okay, great. See, Betaji, for 2027 as well, if you are preparing for GATE 2027, then also this particular series is going to be very helpful for you, because I am going to cover all the topics which is required for your GATE exam. Is it okay? You will be able to solve your all PYQs. If you are going through this series, you will be able to solve all your PYQs. Okay. So it's a very fast course, but covering each and every topic. Okay, now let's come to the SOP. I'm just let me complete the today's topic so that we can conclude. Okay, why the digital word is required and how we are going to design anything. Sum of product form, SOP. SOP stands for sum of product. SOP stands for sum of product. Suppose the equation or the function is given in this way. Suppose the function is given in this way, a b bar c plus of a b c plus of a b c bar. Suppose the function is given in this way. What does it means? This function is indicating sum of products. These are the products. Yes, sir. And this is sum of products. So that is what we call SOP, sum of product. Here each subterm is called min term, or you can say each product term is called min term. Each product term is called min term. In SOP form, each product term is called min term. And SOP is used for output logic 1. So each min term must have logic 1. Is it okay? Now please observe. Let me first show you about the binaries little bit. Those who are not aware, just give me 1 minute. See, we have a different number systems in which binary number system is 1, which base is 2. The base or a radix 2 means only 2 different symbols are used to define any number. Okay, just like decimal number will have 10 different representations, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In the same way, for binary we have only 2 representation, either 0 or either 1. But we can have a relation from any base to another base. Is it okay? So if we have to do the conversion of any base to another base, then only we have to multiply the coefficients with the position value. And here if we talk about position value in binary, we have 2 to the power 0, 2 to the power 1, 2 to the power 2 and 2 to the power 3. Let us suppose we talk about 4-bit. Is it okay? So what is 2 to the power 0 means? 2 to the power 0 will have a position value 1, 2 to the power 2, 2 to the power 1 will have a position value 2, 2 to the power 2 will have a position value 4, and 2 to the power 3 will have a position value 8. Is it okay? Yes, sir. Now please observe here. Suppose we need to write the binaries. Okay. Suppose we need to write the binary of a decimal number. Suppose we need to write the binary of a decimal number. Suppose I am interested to write the binary of 0. So what it will become? 0 coefficient will multiply with 1 plus 0 coefficient will multiply with 2 plus 0 coefficient multiply with 4 plus 0 coefficient multiply with 8. So we will get 0. If we have to write the binary of decimal number 1, then we need to put 1 here, because this 1 coefficient will be multiplied this 1, we will get 1. All other are 0. In the same way, if you need to write 2, you can write 2. This coefficient is multiplied with 2 plus 0, 0, 0. If you want to write 3, then 2 plus 1. 2 plus 1 will become 3. If you want to write 4, then this will be 4. If you want to write 5, then 4 plus 1 is 5. If you want to write in the same way, if you want to write 6, then 4 plus 2 will become 6. How many of you able to understand? This will be multiplied with this will be multiplied with this, all are going to be added. So very simple. Even if you want to write 8, 1 plus 0 plus 0 plus 0. If you want to write say 12, then 8 plus 4, 8 plus 4, 12. If you want to write 15 or 13 or 14, then 12 plus 4, 8 plus 4, 12, 12 plus 2, 14. How many of you now able to write any decimal to binary? Any decimal to binary now you can write. Now you can write any decimal to binary. Is it okay? Great. Now please observe, come back to the here. We are talking about SOP. SOP is used for output logic 1. SOP is used for output logic 1. Suppose I am interested to write min term of 9 in terms of A, B, C, D. Suppose I am interested to write min term of 9 in terms of A, B, C, D. Now the first thing comes in our mind is, what is A, B, C, D? These are the variables. Now in the variables, MSB and LSB is very important. What is the MSB and LSB, sir? If you observe this one, I have represented 0, 0, 0, 1. You are saying that this is the binary of 1. I have represented 1, 0, 0, 0. This is the binary of 8. How would you know? How would you know? You know because you know about the least significant bit is high. Here the most significant bit is high. So the MSB and LSB is very important. When we talk about in terms of variables, then we must have to take care of MSB and LSB. Is it okay? Yes, sir. In case if MSB and LSB bits are defined or the variables are defined, we will take accordingly. In case if most significant bit, this is what we call most significant bit, and this is what we call least significant bit. Accordingly, next significant bit, most significant bit. So when we are going to assign the variables, we must know about the LSB variable, MSB variable, and other significant bit variables. Otherwise, we won't be able to write the min term. Is it okay? So the most important thing is to focus on the MSB and LSB. In case if MSB and LSBs are not defined, then in a continuous series, first one will be treated as a MSB and last one will be treated as a LSB. So here A will be treated as a MSB and D will be treated as a LSB. In the same way, if we have W, X, Y, Z, W will be treated as a MSB and Z will be treated as a LSB. Is it okay? In case if it is not defined, if someone defines, we have to consider accordingly. So if we have to write the binary of min term of 9, what is the binary of 9? 8 plus 1. This is the binary of 9. Yes, sir. And we have to define in the min term. How to define min term? This MSB I am because it is not mentioned which one is MSB and which one is LSB. So in a continuous series, first will be taken as a MSB. Second, next significant bit, and least significant bit. Is it okay? Yes, sir. Every min term is a product term. Min term is a product term. So I am just making product. Min term is used for output logic 1. So you have to represent this such that it will represent logic 1. So what is A? A is 1. We can keep A as it is. What is B? B is 0. So its bar is 1. What is C? C is 0. So its bar is 1. What is D? D is already 1. So if I represent like this, then for a condition of binary of 9, we will get logic 1. So this is the min term of 9. How many of you now able to understand? मशीन पढ़ने का वेट कर Great, great, great. How many of you now able to understand this min term of 9 in terms of ABCD? Great. In the same way, can you tell me what is the min term of 5? Can you tell me what is the min term of 5? Can you tell me what is the min term of 5? Can you tell me what is the min term of 5? Can you tell me what is the min term of 5 in terms of W, X, Y, Z? Can you tell me what is the min term of 5 in terms of W, X, Y, Z? What is 5? 5 for 4 bit, how to represent 5 in a 4 bit? 0, 4 plus 1. Is it okay? I am hoping now you can see that 8, 4, 2, 1. For 4 bit binary code is 8, 4, 2, 1. Is it okay? For 5 bit it will become 16, 8, 4, 2, 1. Now all of you can easily do what is this decimal equivalent. Yes sir. 1, 2, 4, 8, 16, 32, 64. 64 plus 32 plus here we have 8 plus 4 plus 1. So all of you know how to represent the decimal or binary. Is it okay? I have made that very simple. So all of you now able to understand what is the binary of 5? Yes sir. 0, 1, 0, 1. Now can you write, because MSB and LSBs are not defined, so W, X, Y, Z. So here W is 0, so we must need to put bar. Then it will become, W bar will become logic 1, because you have to multiply and this min term must give logic 1. 1x as it is, y 0, so bar is needed, z as it is. So what is the min term? Min term we have W bar X, Y bar Z. Great. How many of you able to understand? Great sir. Now let's have a discussion why we are studying this SOP and POS. Suppose we have to implement a function. Okay, let me write down. Find the minimized expression for the truth table shown below. Now see, any user come to us, we are an engineer, we are a designer, so any user come to us and ask to design a circuit. So let us suppose one user came to us and he asked to design a digital circuit here, and this digital logic he needs a 2 input. Okay, he is saying that I need to design a digital circuit in which we have 2 input and 1 output. Okay, let us suppose he want to design a train light system in which based upon the 2 trains running on the same consecutive running in the same direction onto the same track, their speeds are going to be compared and accordingly the traffic signal will be done, green, red or yellow. Is it okay? That is what we call a comparator. Here I am just telling about one signal, that is either green or stop for the back train. Okay, so he asked me to design this kind of circuit. He asked me to design this kind of circuit A, B and output Y. Is it okay? He asked me to design a circuit. Is it okay? Sir, it is a bit position in the binary number system holds the greatest numeric value. Yes, that is what we call MSB. You know how to use the Google and ChatGPT. Great. So, is it okay now? Great. Thank you, Betaji, for writing in such a good way. Now, please observe. See, it's a kind of crash course. So, accordingly, I just wanted to, you have all the value, all the knowledge that is needed. Is it okay? Instead of going with lot of theoretical content. Okay. So, please observe here. Suppose you want to design suppose you have a 2 trains A and B, and based upon that the signal for the B train will get on. Okay, so if they are stopped, then stopped, there is no green signal for this B train. Okay, if B train is at higher, then also your green signal must be 0. Otherwise, the back train B will get hit A. If A train is running faster than B train, then your signal will be high. Is it okay? If both are running at same speed, then also your signal can be a green for the back bulb. In that way, user asks you to design a digital circuit. You will understand the user concern, what he want to design, and then you can construct the truth table accordingly. In this particular question, already the truth table is given. Now, how many of you able to understand? User, whatever user requirement, he put a requirement in front of us. We understand, and then we will create a truth table first. From the truth table, next step is, truth table means all the possibilities of input combination and output. So we have 2 input, total number of possible combinations are only 4. Either both are low, any one of them is high, or both are high. And what we want for train signal B to be high, only either A is ahead or A and B are onto the same speed. Is it okay? Great, sir. So accordingly, I put a logic level 1 for the output. We have a truth table as per the user desire. Next is to construct. Next is to write the logical expression. Now please observe, 0, 0 is the binary of, 0, 0 is the binary of, I am talking about AB. AB are the inputs and this is your output. So if we talk about input AB 0, 0, 0, binary of 0. And this 0, 1 is the binary of 1. 1, 0 is the binary of 2. And 1, 1 is the binary of 3. This is the greatest beauty of binary number system, that in the consecutive we can see all the possible combinations of the input. Is it okay? Yes, sir. So now we have 0, 0, 0, 1 and 1, 1. Next. We can check the output. So output is high on which binary combinations? See, we can write output logical expression as, one way to represent the SOP expression is summation of min term. All of you know about the symbol summation, small m represent min term. What are the binary conditions where we are getting output logic 1? On the binary of 2 and binary of 3, which is in terms of A and B, and A is a MSB and B is a LSB. Is it okay? Yes, sir. Now, you can also write the min term. What is min term? What is the min term here? Min term, SOP is used for output logic 1. SOP is used for output logic 1. So, our min term is a product term. So, what is the min term here? Sir, A is 1 and B is, sir, A is 1 and B is 0. So, if you write here, it will become A dot B bar. A dot B bar is logic level 1, which is showing that output is 1. Here we have A is 1, B is 1, so A dot B. Is it okay? So, SOP means summation of sum of product. So we have one product term A B bar, that is the min term of 2 plus min term of 3. How many of you now able to understand? Great. Can we directly implement the function? No, sir. If we directly implement the function and give to the user, the circuit maybe gives a false output, or either we have to use some hardware interrupt, or we can do the minimization, the best possible thing. So best is to go with the minimization. We can take A common, so B plus B bar reduces to logic level 1. Now we have A. Now we can design a circuit and give to the user whatever the user wants. This is the signal. Now I can ask, please give me the money. I have created what logic circuit you want to design. In the same way, entire digital world is designed. First, need to understand the user desire, construct truth table, write logical expression, minimize it, implement the logic circuit. Your entire digital world will be constructed in a very simple way. How many of you now able to understand, beta ji? Please let me know by writing the comment section. How many of you now able to understand? Please let me know by writing the comment section, beta ji. Great. So, still I have 10 minutes, and in the 10 minutes I can conclude this SOP and POS. How many of you now able to understand this SOP and POS? Great. Those who are in first year need to do the revision. Those who are in second year need to do the revision. Third year and final year student, I'm hoping all of you able to understand it very good in a very good way. Just you need to take the notes and go through the notes 5 or 10 minutes. That's all needed for the upcoming class. Is it okay? Let me complete the POS form, product of sum as well. So product of sum, POS is called, POS is used, product of sums. POS is used for output logic 0. POS is used for output logic 0. Each sum term is called max term. Let me show you an example of POS. So POS expression is represented as, POS expression, suppose we have a function of ABC, then it can be represented as A plus B bar plus C dot AB plus B plus C bar dot A bar plus B bar plus C. This is the way we represent POS. Each subterm is a sum term. Each subterm is a sum term, and this term is called as max term. So each sum term in POS expression is called max term, and POS is used for output logic 0. That is why we have represented AND operation. If any one of them is 0, we are getting 0. Now please observe, suppose we have to write the max term of 6 in terms of A, B, C, D. In terms of A, B, C, D. Can you write the max term of 6 in terms of A, B, C, D? Sir, how to write the binary of 6? For 4-bit, if we have to write the binary in 4-bit, then 0, 1, that is 4 plus 2. How many of you able to understand? This is 4 plus 2, 6 for a 4-bit. If we have to write in 5-bit, we will represent like one more 0 in the ahead. Is it okay? Yes, sir. Now, please observe. Which one is MSB and LSB? Again, we are concerned. If it is not given in the continuous series, we will first take the A as a most significant and D as a least significant. So this will become A, B, C, D. Now, each max term is a sum term. So I'm just using plus symbol. Now, please observe one more thing. Each subterm, each max term must give output logic 0. So the max term is such that this term is giving logic 0. If any one of them is 1, we will get 1. So this must be 0. A is already 0, so we will keep A as it is. B is 1. If we make B bar, it will become 0. C is 1. If we make C bar, it will become 0. And D is already 0. So the max term of 6 is A plus B bar plus C bar plus D. How many of you now able to understand, beta ji? How many of you now able to understand this A plus B bar plus C bar plus D? Great. Can you write the max term of 6 in terms of A, B, C, where C is MSB and A is LSB? Can you write now what is the max term of A 6 in terms of ABC? Now we have 3 bits. So what we write for 6? Binary is 0, binary is 110. What is the MSB here? It is defined in the question that MSB is C, LSB is A. So we have to write C, B, A. How many of you able to understand? Again, this is plus, but this term must give output logic 0. So this term must give 0. This must be bar, this must be bar, A as it is. How many of you now able to understand? That is not A bar, B bar, C. That is C bar, B bar, A. Because MSB and LSBs are defined differently. Very important thing. Why we are concerned with the MSB and LSB? Because if you are not able to understand MSB and LSB, you will do the wrong thing. How many of you now able to understand, beta ji? Great. Now the last, let me show you once again. Can you write the max term of 13 in terms of WXYZ? Can you write max term of 13 in terms of WXYZ? Yes, sir. What is the binary of 13? 1, 8 plus 4, 12 plus 1, 13. Okay. Yes, sir. 8 plus 4 plus 8 plus 4 plus 1. We all able to see 1, 2, 4, 8, 16, 32 and so on. So now we have W plus X plus Y plus Z. MSB, LSBs are not given, so we will consider the first as a MSB in the continuous series and last one as a LSB. So this will become your max term of 13. How many of you now able to understand how to write the max term and min term? Great. Now please observe. Find the minimized expression. Find the minimized expression from truth table shown below. Now I am hoping all of you able to understand what is truth table means. Truth table will have all the possibilities of inputs and the corresponding output. Is it okay? Yes, sir. Now please observe here. The truth table is given to you like this. We have A, B and C. So with the two inputs, truth table is the table between inputs and output. So we have two input A, B and output Y, where I am writing A as a MSB and B as a LSB. Okay. Here we have a possibility, total 4 possibility, either both are low, any one of them is high, or both are high. Is it okay, beta ji? Yes, sir. So which one among them you want to keep high? I am giving the opportunity to you. Just tell me what particular output you want. What do you want for 0, 0, 1, 0, anything, whatever you want for 0, 0. For 0, 0, for 0, 1, for 1, 0 and for 1, 1. Whatever you want, just tell me. Sir, for 0, 0. Suppose you want for 0, 0, 0. For 0, 1, 0. For 0, 0, 0. For 0, 1, 0. For 1, 0, you want 0. For 1, 1, you want 1. Suppose you want to have this. Okay, someone is saying, sir, 1, 0, 0, 1. Let's take that one. Okay. So the first, I got this. Okay. So let's take this one. Okay. Sir, it's 1, 1. I have done the 1, 1. Gate Aerospace, sir, please make it possible. Okay. I will try to like pass your request. You want Gate Aerospace Engineering also, so I will pass your request. Let's see, because the number of students are very few now. So sometimes we have to see the feasibilities as well. But okay, as you requested, I will try to forward your request. How many days it will take to complete? I will complete it within 10 to 12 days and complete. Everything will be completed. Okay. So now please observe here. What is 0, 0 means? 0, 0 means either you can go with SOP or you can go with POS. Presently we are going with POS. This is the decimal. 0, 0 is the binary of 0. 0, 1 is the binary of 1. 1, 0 is the binary of 2 and 1, 1 is the binary of 3. So what are the positions where we are getting output logic 0 in this question? What are the positions where we are getting output logic 0 in this question? Please observe, beta ji. Sir, we can write output logic Y as pi of M. What is the notation? Pi of M means pi represent product. Capital M represent max term. So pi of M, product of max term. where we are getting output logic 0. POS is used for output logic 0. So we are getting output logic 0 at 1 and 2. Is it okay? Yes, sir. And what is the max term? POS is used for output logic 0. So what is the max term we get here? Max term is a sum term. So here we get A plus B bar, A plus B bar. And here we will get for 2, max term of 2 is A bar plus B, A bar plus B. So what we are getting? We are getting A plus B bar and A bar plus B. How many of you now able to understand, Betaji? Great. So can we do the further minimization? We can just open it because already it is minimized only. It's a minimized POS expression. It can't be further minimized in POS. So this is a minimized POS. However, we can even write a minimized SOP as well. So A into A bar will become 0. AB plus B into A bar. So A bar B bar plus B bar will become 0. Is it okay? So what we are getting here, this expression is, we are going to learn in the upcoming lecture. This is a expression representing NOR gate. So basically this is A XNOR B. NOR is a symbolic representation that we will going to learn in logic gates. Okay, but presently since we are getting this function, so I am writing this A XNOR B. Is it okay? This is a symbolic representation of XNOR that we will see while studying the XNOR gate. Logic gate is going to be started tomorrow. Now please see here. So whatever a designer, whatever a user wants, the designer easily design it and pass it. Is it okay? So what we will get? A XNOR B as a output Y. So just need to have one digital device called XNOR gate, and then designer will design like this and ask for a money that whatever user wants I have designed. One very important thing that you have to be noticed here is, can we go with the SOP as well? Yes, we can go with the SOP in the same truth table. SOP is used for output logic 1. SOP is used for output logic 1. Is it okay? So where we are getting output logic 1, can I write summation of min term? The expression is same for the summation of min term 0, 3. So if we have a total 4 possibilities, 0, 1, 2, 3, out of these 4 possibility, 1 and 2 binary have output 0, then remaining 0 and 3 must have logic 1. Very simple. So if this is your min term, this is your max term, you know about min term. If you know about min term, you know about max term. If you know about max term, you know about min term. If you know about min term, you know about max term. Is it okay? Great. So how many of you now able to understand, Betaji? And if you go with the 0, 1, you know how to write for 0, 1 as well. For 0, 1, what is the min term, Betaji? If you want to write the logical expression by using min term, there is no issue. You can write it as A bar B bar, and here we have AB. So you can write as A bar B bar plus of AB. How many of you now able to write from SOP to POS and POS to SOP? Please let me know by writing in the comment section. I need your experience as well. Would you be able to understand today's class? What we have learned in today's class? We have learned first of all the basic operations. Now we know about the 3 basic operations, and or not. Second, I told you how to take common to minimize the logical expression. Third, we learn in the SOP expression, if we have a min term, we can use the single min term to take multiple commons. Okay, we can utilize the one min term to take common from the multiple other min terms. Third, we have learned about the transposition theorem. Hoping you will be able to understand. Multiply same result in 2 bracket plus different result in the plus different results in the brackets. Is it okay? Then we have learned distribution theorem. Distribution theorem can be utilized as per the observation. If we have A plus A bar B, it can be clearly observed A plus A bar can be possible. So we will go with the distribution. Then consensus theorem. In consensus theorem is used when total number of variables are 3 and each variables must be twice in the expression. Only one variable is complemented or uncomplemented one. Then we have learned uh, canonical and minimal expression format. And then lastly, we have observed De Morgan's law. De Morgan's law, if we have a plus b plus c whole complement, then with the break of the complement, the symbol plus will be inverted with dot, dot will be inverted with plus. Is it okay? Yes, sir. And then we have seen SOP and POS. Also, we see how to write binary of any decimal number and how to identify any decimal number from the given binary number. We have also observed the way we can use to design any digital circuit in our entire digital world. First, user come to us, ask to have certain set of conditions for the logic. We will understand it, construct a truth table, write logical expression, find the minimized SOP or POS expression, then implement the logic circuit. Minimize it. The most important term is minimize it and then implement the logic circuit. Can you please let me know how many of you able to understand as well as able to revise the entire thing? It will hardly take only 2 minutes to do the revision. Today, during your sleep, you have to do the revision. Okay. Hoping you have enjoyed today's session a lot. We'll discuss rest of the part tomorrow. And those who are watching in a recorded format, I'm asking again and again, please mention your feedback, whatever you want in the upcoming sessions, as well as in which year you are and in which program and branch you have, okay, and which year you are going to give the gate. So thank you everyone, lots of love. Thank you everyone, lots of love. Good night. Good night.